Hello, everyone. Thank you for coming. Appreciate you attending my talk. My name is Mark Pollack. I've been with the Spring team for a very long time. The last time I think I was here was 17 years ago with Ramnivas Ladad, who spoke about AOP. No one talks about aspect-oriented programming anymore, but it's still pretty cool. Maybe we'll even use it in Spring AI. So what we're going to cover today is a very, very recent project. I think everything in the AI space since ChatGPT has been released into the world is pretty new. I hope you ask questions at the end, and I'm happy to take them. So this is sort of like a little bit my personal history of how I got to be on this stage in some way, and maybe it's a similar pathway to you as a Java developer. Yeah, ChatGPT, maybe this should be in big font and exploding. But this was, a big explosion last November. I got COVID in January, and lying in bed gave me an opportunity to screw around with this for a while. And I've always had some exposure to this. The gray hair means I've been around for a while. And neural nets in the 90s, like late 90s, I guess, they were interesting. I had used them to classify things in particle detectors. But even at the time, everyone said, oh, it looks like it works, but we really don't know why it works. So we just went back to using the regular algorithms. And every so often, there'd be a Udemy or a Coursera course, and I'd say, oh, I think I'll take that. I'd get like halfway through and say, I don't really feel like cleaning data my whole life and training models. It's just not for me. In terms of other popular attention, there were like these big seminal moments in popular culture where a computer finally beat a grandmaster in chess, and then taking it up one level more, a computer from DeepMind, later acquired by Google, beat a professional or world-class Go player, and in particular made a move that no one had ever seen before. But still, it felt like a walled garden. It's like those guys over there with their computers that they bring in, on their container ship. Yeah, that's not for me. But as I said earlier, ChatGPT really changed all that, especially for me. Had an accessible API, and alluding to my aversion to doing training, they were pre-trained models. So you can just get up and go. And they had a very large knowledge base, which is frankly incredible. I heard it's only 700 gig once it's compressed all down. So all of the questions you ask it could fit on your phone, right, in terms of the world's human knowledge. It's kind of crazy. And I started exploring code generation. That was sort of my first itch that I wanted to scratch, because it's not just trained on human language and interaction and knowledge, like in the sense of facts, but it is trained on structured code. And I think that's becoming a little bit more prevalent now if we start interacting with it and ask it to generate code or submit code to analyze. So I was continued to be very impressed and just kept pushing and pushing it, and eventually started to make a project called Spring AI. And I think all of this has a big caveat. You're here talking, making it seem like I'm an expert. I'm not really an expert in AI. My history isn't from that background. But I think if we look fast forward, even 1 year, right, let's say 5 years, we'll somehow categorize this as like the CGI bin equivalent of the web days. We're just at the point of getting a cat, animated on the screen with terrible fonts. So I think, whatever we see here is a quickly changing landscape. But I hope to give you an introduction, and we'll see how it goes. This sort of reinforces, I think, the point. A lot of the way I got educated about AI was through podcasts. There's one called the Practical AI Podcast, which I'd highly recommend. And there's a host of that show, Daniel Witnack. He's a data scientist, speaker. He speaks at quite a lot of AI conferences, so he knows what he's doing. And it's funny to hear him describe how his job is changing. Right? And these are sort of the quotes. That he'll take on a client and then say, well, to solve this problem, as a data scientist, what I'm going to do is I'm going to build a model, gather some data, and train it. And you can almost see like the disconnect in his mind as he's talking saying, well, I can solve a lot of problems without doing training. And now I'm doing this sort of engineering. It's like, he's totally out of his comfort zone, right? Because now it's really becoming the domain of application developers to interact with these APIs and build software. So yeah, the P in GPT is pre-trained, and I almost view this as like the new database. It's no longer the realm of just Python. You know, to take the analogy a little further, it's sort of like saying, well, I made a new database, but you can only access it from Python. It's like, what are you, crazy? You know, that doesn't make any sense. It's going to be ubiquitous. People want to access it from all languages. So I expect there will be frameworks, you know, blossoming over the next year in every part, you know, of the ecosystem. So the consequences for Spring developers or Java developers more generally is that a software background is super essential. So it's like almost we have a little bit of a leg up in one area of building solutions. And the things that you need to bring to mind when thinking about creating an AI solution, it's not just calling the model, it's kind of everything around it. Data access is a big deal, how you process data. So you might think of some of the things we're doing almost like as ETL, extract, transform, and load pattern that goes back ages, but for the AI domain. Batch processing, it never dies, still has a role here, and you'll see that in a minute. And then as you get more sophisticated in terms of building an application, what you see is sort of similar to enterprise integration patterns, like the classic use case or demo app in integration patterns is I have a cafe and they make hot drinks and they make cold drinks, and cold drinks go down one processing pathway, hot drinks go down another, then they meet up. To solve a sophisticated use case, you have to make multiple calls to the model. And sometimes the result from one call is going to lead you down different pathways. So it has the same shape as sort of an integration problem. So there are a lot of tools in the Spring ecosystem to handle batch and integration. And I'm not going to show any specific examples of that type of integration, but I see that coming forward in the future. So here's the world's simplest app, basically, right? It's using a class in Spring AI called AI Client. AI Client is a portable abstraction, so you can invoke different AI models that have different APIs. So far, what we support is OpenAI and derivatives of OpenAI. Some of them have slightly different APIs. Azure is another example of someone who's partnered with OpenAI. Hugging Face endpoint service has access to hundreds of models, probably thousands of models you can access with Spring AI. And we're building out more. Amazon Bedrock, Google Vertex, those will be on the roadmap. And there's some people from those companies we're collaborating with. So I'm going to try to get started with something new. It's always hard to introduce two new things, but this is my other side project. That's actually the side project that got me started with AI. I was always jealous, basically, of seeing in the JavaScript ecosystem how the tooling evolved essentially quicker in some way than the Java ecosystem. So I was thinking to myself, where's my Create React app? Like, we don't have one. Like, well, I'll make one, right? So there's a separate project called Spring CLI, and the equivalent of Create React app is Spring Boot New, creates a web app. But you don't always want to create a web app. So you can have reference other code repositories. So unlike start.spring.io, which just gives you dependency with no code, this takes a current existing sample app and slightly refactors it, for example, giving it this package name. And in the middle here says from AI. That's an alias to a GitHub repo. So we'll do that now. This is the another experimental project. They're all going to graduate soon, but right now, sort of incubating state. So let me go to here. Or I'll just do this quick. So what you get is a little README. It explains what it's going to do. Well, like Nagware. I don't know what that's doing. And you have your, let me get rid of the preview. Sorry. Don't usually use VS Code. So you get your starter. And here is the key thing that creates that AI client through auto configuration. If we take a look at the code, it's very simple. It mimics basically the sample web app you see on the Getting Started guides on Spring.io. And it's just passing the message through. And the default one value is tell me a joke. So if I go here and do Spring Boot run, that's not good. Build failure. Oh, I already have something running. Crap. I think I have my other demo running in the background that I didn't turn off. Let me turn that off. Okay. So big. Yeah, here's a classic one for you. Why don't scientists trust atoms? Because they make up everything. Yeah, everything's a dad joke. It doesn't have a good sense of humor. Needs more alignment. So there you go, hello world in 2 seconds. Let me go back to the slide. So yeah, as I mentioned before, this is a new project. It's been inspired by what I would say are the current popular projects in the Python ecosystem. This is coming out of the Python ecosystem, but getting more widespread. It's not a direct port. It's more like studying that code base, looking at the ideas, seeing how they can be improved, adapting them to more of the idioms that you would expect if you're a Spring or Java developer. And one thing that was amazing to me was hearing podcasts of both these authors describing their framework, and I thought to myself, they could be describing Spring, basically. They really have a lot of component abstractions, pluggability. It's a perfect fit, I think, right, to that type of way of thinking about going about building an application framework. In terms of use cases, I know there's been many talks about AI at this conference. I'm not going to go into detail. Hopefully the other talks are supportive of understanding what you can do. One of the most popular ones is question and answer over your docs, right? This could be, developers think it's their reference docs for their APIs or their project. But this could be, financial forms, 10K forms, filings from companies. Could be medical information from the government. One project we're just starting right now is to help Medicaid. That's the program in US for healthcare. For recipients of this program to query, what type of products and services they are can get, right? And I've gone through the website. It's your typical government website that tries but fails, right? You type in the search box, you get a bunch of PDFs, and then if you're an 80-year-old woman or man, you're like, well, what the hell is this, right? So hopefully maybe chatting with a text box will make that more accessible. So I think there's a lot of great impacts this can have. There's also bad impacts. We could talk about that in the hallway. And the project aims to provide the key components for creating AI apps. So this is a diagram from the venture capital firm Andreessen Horowitz. I think they've updated this diagram since, but I feel like it provides a pretty good layout of the different components. And it's probably, on this screen, it's not hard to read. Wow, that's like the first time. I did do this to make it easier. Basically, these are specific products listed. It's almost like a crap table where the VC fund is putting their chips, right? And they're hoping one of their chips becomes a winner. So what you have on the right here are models, and there are lots of models. Of course, the big players, Google, Amazon, OpenAI, Microsoft, they all have, I think recently now, Amazon did a big investment in Anthropic's Claude. So they all kind of come paired now. It's like they're all pairing up, these big companies. But there are other smaller companies, and there are lots of interesting models you can run on your laptop. The space is evolving pretty quickly. So it could be hosted, it could be on-prem. Your app might use multiple models, which is totally normal as you get more serious and start thinking about what's cost-effective. So that's on the right. In the middle, I guess, is an AI framework, poorly formatted, that kind of orchestrates this. You have things like caching. If you ask the same question twice, don't waste time calling a hosted model. Sometimes that could be semantically the same question twice, right? So it's kind of maybe a little more clever than just string textual matching for caching. Ops and evaluation, I'm not going to show too much about this, but I think this is a huge, huge area. It's definitely going to be an area of focus for us in the Spring AI project. I think we're at the hello world stage. You see something wiggling, you look at it with your eyes, and say, hey, that worked, right? Maybe do it 10 times. But really, if you formalize how you're evaluating how effective it is, you need something automated. You need some way to get a score, essentially. Like, how is my app that I'm making working? There are a lot of knobs. We'll see some of the knobs you can twist in a moment. So how do I know I made progress in my app to be better, right? And better, is defined a little unusually, right? It's not just all tests are green, right? It's like, is this providing an effective answer? And there's a lot of dog fooding here. So like, how can you tell that the answer was appropriate for the question? Well, you go back and you ask the model, and it can kind of give you a score. It's weird. There's a lot of ways you can use the model itself to sort of bootstrap your evaluation and use of it. Prompting tools, we'll get into prompting in a minute. The 10,000-foot level is the text you enter, but how you do this is super important. It's hard to understate or overstate how important it is to form effective prompts. An example of that is, this is ChatGPT. It wants to talk. So if you say, please give me the result in JSON, it might reply with the text, sure, here's your JSON, Mark, and then start the curly brace. You're like, that's not what I wanted. I just wanted the curly brace. Then you have to go back and kind of convince it more and more and more to do the right thing. So you're not dealing with SQL, right? You're dealing with human language as the basic interface. So it makes for some strange sentences, like it was a research paper which was evaluating prompts and their effectiveness. And one of the best prompts they found was almost like a cheerleading prompt. It was like, you can solve this problem, you got it, don't worry, take it step by step. Like that's from a research paper, basically like encouraging a child to say, don't get confused, take it slow. I think that was it. Take it slow, you can do this, do it step by step. That was the exact phrase. Ops comes into that as well. How do you know that the solution you're using is working well? How do you know that someone's not doing anything nefarious, right? On the top, over there, left, it says contextual data. This is the ETL part that I was talking about. Kind of moves from left to right. I mean, you can't see all the labels for the arrows and the colors and what they mean. But basically, bringing your data to the model is super important use case. That's how you do question and answer use case. That's how you do summarization use case. So you start from your PDF, let's say, and there is some cleaning here. Not as bad as training a model in my mind, but you parse that PDF, you scrape it, you modify it, you massage it. Then you make this thing called embeddings, which is just a computer representation of words, and you store this in a specialized database. So just like there are many models, there are many vector databases, and we support 5 or 6, and the number probably go up to 10 or 20. We'll see in a year. It's kind of almost like the NoSQL key value stores. Like in the beginning, there were like 50, and then kind of whittled down. So there's a lot of pluggability both in the models and in the vector databases. And last but not least, you have to host this somewhere, and there are more platforms emerging that are a little bit more rich and self-contained for this case. So we'll try and go over some of these. I'll show code more in a minute. I think maybe 3 of these I'm going to go through, the models, the prompts, and using your own data. So there's a lot of ways you can categorize models. Now you have to shop around basically for the model that's appropriate for your use case. Spring AI, and as well as LangChain and Lang4j, they're really focused on text/code, but there are others, right? You can start with input as an image and get out an image. So before ChatGPT last summer, people may have played with Midjourney and Stable Diffusion. These were, type in, I'd like to see a picture of a cat with a punk hairdo, and out pops a cat with a punk hairdo. And it was great. You go to a bar, impress your friends, but it didn't catch on as much as ChatGPT did. And the trend is to go what they say is multimodal, meaning you won't have to shop around much for a different model if you want to do image processing or video processing. It'll all just kind of be one. And ChatGPT has claimed to be multimodal, especially with GPT-4 now for 6 or 7 months, but really haven't surfaced it all that much until recently, I think a few weeks ago. And it hasn't yet really surfaced in the API. So it's a slow march, but yeah, this is one of those examples. In a year's time, there'll probably be much more consolidation about models, especially these big foundational models, becoming like a one-stop shop for image, video, code, language, input and output combinations. The downside of, well, there are many downsides to AI. I'm sure you've all read about them in your editorial pages. But in terms of how we need to address this as programmers, the big one is hallucination. Sorry. It really wants to talk. It really wants to converse. And so it'll lie. Like when I was doing research for Spring AI, I'm like, yeah, this ETL pipeline, this looks familiar. Let me ask ChatGPT, what projects there are, that use, a particular, programming paradigm. And sure enough, it came back. It made a beautiful abstract for a project called Spring ETL. It's like, this project doesn't exist. It just made it up. So you have to really be careful and check what you're doing. And there are ways to control this, but it's there. It's definitely there as a thing to be aware of. Your tool is lying to you. So let's move on to prompts. As I was saying before, this is input that directs a model to produce an output. And you have to get very specific. And it's so important that the new term prompt engineering has come up. So it's like people can just spend days focusing on making a prompt. And that's when we get to the code generation. That's a good example. I spent weeks focusing on that one prompt that I'll show you. And in order to save time, once you find a good prompt for a particular use case, you want to share it so that other people don't spend a week figuring it out themselves. And again, a weird case of dog fooding. You can ask AI itself to create prompts given the initial prompt and try and improve it. It's very weird. I think there were, so here are a few links. I have a little QR code at the end for a link to the talk. There's some guidelines from OpenAI. I took this course from, what was it called? I forget the name of it. What was it? Yeah, Deep Learning AI. This short course was done also with an engineer from OpenAI. And there are little tips and tricks in there. It understands placeholders and kind of, some formatted structure of the text. Definitely worth taking something in this vein to understand the subtleties. And prompts in Spring, in the first attempt at managing this, it relies on a text templating engine. Very often you spend time creating this prompt, and then you have little placeholders in it, just like MVC. And so that sort of paradigm is what's carried over into Spring AI. So we have a class called prompt template. It's stateful, so don't think of it as JDBC template, passing it all around. It's a utility class. And here's an example. You give it instructions. You give it very specific instructions, right? Like not just bullet points, but how many you want, how many words. And then, this is a question and answer type of thing. You give it context, the background of the problem you're asking, the question you're asking, and then you have the question, which usually comes from the user. So it's straight up, super simple, templating. It's not like you're iterating, making a table. I mean, I suppose you could, but really just simple usages of the text templating engine are all you need to get going. So here's an example. Tell me a blank joke about blank, right? Funny joke about something. Cows. And then you get the prompt template. You say render on the model, pass that into the AI system, and get back a string. So we'll do that here. Go back to this. So I have some sample apps from a workshop we've done. Oops, I guess I hit this. Oh, I have to stop the other one, sorry. Okay. Yeah, so this is running the same thing. Why did the tomato turn red? Because it saw the salad dressing. All right, so here's one where we pass in some, oh, I thought I had a more updated one. Anyway, oh no, this is the wrong, sorry, I wanted to do the, my apologies. Yeah, where is my, I have to look for cow. Oh, prompt template, here we go. So this is what the code looks like. I'll run it in a moment. So the joke prompt lives in a file for a string template. So if I look at the joke prompt, that's what we saw on the screen. Simple web controller to pass in the adjective and the topic. And then, oh yeah, so instead of passing strings, I kind of maybe skipped a little bit ahead of myself. String is not the best way to pass in stuff, right? OpenAI has kind of like really changed the world of how you pass information. Now you have roles, and we'll get to that, and you have many messages. You have a system role, a user role. System role is kind of like the context, like you're an AI agent that tells jokes, right? Tell it in the voice of, you know, Robert De Niro, right? And you could, that's the context. Now every time you ask a joke, it'll say, hey buddy, here's a joke, right? Something like that. So that's what prompt is. So the next level of calling generate is to pass in the prompt. So I kind of got a little out of order here because I was trying to cram down this workshop into a 45-minute talk. So let me call this one. I forgot where I had the curl here. Oh, here it is. Yeah. Yeah, so this is the great audience participation. Instead of a cow, I need a noun like Mad Libs from the audience, a noun. Raccoon? All right. Why did the raccoon cross the road? To get to the garbage can on the other side. Yeah, okay. And I'll briefly show the roles as well. So I was saying there's a system role, kind of sets the context. So, you know, you're a helpful assistant. You help people find information. Your name is name. You should reply to the user's request with your name and in the style of some voice, right? So everything is going to be answered with this type of context. And I'll pop open the code for that. We can look at it, be easier than... So here is this prompt template for the system resource, right, which is the system message, which is what I showed before. You're an AI assistant, blah, blah, blah. The user message is just created from a string. I combine these two things into a prompt, pass the prompt, and get a response. So if I go back to the, oops. So the default is, what was the default? Yeah, tell me about 3 famous pirates. Your name is Bob, and you speak like a pirate. Oops, I keep going to the wrong one. Sorry. I'll just do that. This will take a moment. He goes, ahoy there, matey, I be Bob, you know, your trusty AI assistant at your service, and blah, blah, blah. They didn't actually give 3. That's pretty bad. What was the sample response from before? Yeah, it gave Blackbeard and blah, blah, blah. Surprised. Anyway, this is why you need evaluation. You do it 10 times, you know, and 9 times it works, and 1 time when you're in front of a big audience, it doesn't work. So let's talk about some of the limitations of AI models. Their training data set, large as it is, currently has information up to basically 2 years ago. So if you ask it for information for something that happened after 2021, it doesn't know, and sometimes it even makes up a story because it's sorry that it doesn't know. So the reason, yeah, this is maybe the best slide. But let's just talk about tokens for a minute, because this is where you get into the limitations of the AI models, or one of the limitations. So tokens are basically converted from words into numbers. So 1 token is 1/4 of a word, or all the works of Shakespeare is, you know, I think it's 900,000 words is 1.2 million tokens. And that's how the AI model processes data. And for hosted models, you're billed on how many tokens you pass and how many tokens are sent back out, the total amount. So you have space, right? It's almost like you're back in the days of having a Sinclair here. I got 4K. And anything larger that you send to it other than this 4K token limit is just simply, you know, spilled on the floor. So of course, this becoming one of the techniques to give it contextual information about what you'd like it to answer that it doesn't know about, they've increased the size over time. So ChatGPT 4 has like 3 variations. Claude from Anthropic is 100K token size, and there's research papers from Meta making it 1 million. But you know, even if you could send it all the works of Shakespeare to a hosted model, even not hosted, but hosted models may be more transparent because you're literally billed on how much you send. You wouldn't send all the works of Shakespeare if you're only asking about Hamlet, right? You just send Hamlet. So that's where, you know, we'll see this ETL pipeline, and preparing data ahead of time for it to answer is a super important use case. So this is sometimes known as the context window, kind of colloquially, and that's how I'll refer to it here. So there's 2 ways. Let's call it the data scientist way and the software engineering way. Right? The data scientist way is to fine-tune the model. And this is getting easier, but it still involves, you know, pretty extensive knowledge of the underlying model. And the model in abstract has, you know, billions of parameters. They all have weights, you know, billions of weights. And so you need significant, for the large models especially, you need significant computational resources to do this. You know, no one could probably buy an H100 chip from NVIDIA right now unless you have a direct line to the CEO. So sometimes it's not even really possible. But you know, we're all taking our first steps here, so let's start with the easiest, right? And then maybe eventually, you know, we can learn how to do the more sophisticated data science way. And yeah, colloquial is called like stuffing the prompt. Think of it as like SQL injection, but in a good way, right? We're going to take, you know, stuff, right, our data, and literally put it in the prompt in one of these placeholders. So the example, for whatever reason, that's popular, I guess because OpenAI popularized it, is to ask it about the 2022 Winter Olympics. And you get the article on curling. The article on curling turns out to be around 9K tokens. So we'll get to how you ask questions about the entire Winter Olympics in a moment. So you literally put in the entire content of the Wikipedia page here, and then ask it a question. So I'll demo that now. Let me clear off some of these so I don't get more confused. Yeah, so if I go to the stuff controller, here's the Wikipedia article, converted into Markdown thanks to a great utility called Pandoc. Apparently, wiki syntax is totally undefined in terms of a grammar. Where did I put it? Oh, here, data. No, docs. All right, so that's the whole article converted to Markdown. This is the prompt I was showing you before, QA prompt. Use the following pieces of information, context, there's the question. And what I have here is a Boolean that determines, does the context get stuffed or not? And there's a default question with athletes, one, the mixed doubles, gold medal. So that's just the simple logic around that. And first we'll curl it with false. So sorry, don't have that information. See, sometimes it says, I can't predict future events, which wasn't really the question, right? So it got better here as compared to the last one. So now we'll pass that information along. And you see, Stefania and Amos, they won, right? And you could ask the questions all day long. So as I was alluding to with the Shakespeare analogy, you have limits. You can't fit all your data in the prompt. And what has evolved as a term is called Retrieval Augmented Generation. And a lot of people just call this RAG, the acronym. And it's a technique to present to the model only the relevant data for your query. And we'll talk about it. But in a way, you can think of it as Googling something, getting the top 10 results, and then handing those top 10 results to the AI model. So at the high level, there's like two phases to this. One is, let's call it the batch phase, right? You have to prepare the data ahead of time. And so you get all the Wikipedia articles on the 2022 Winter Olympics, and now you have to chop it up. Remember, we're going to have to fit it in a window, right? So maybe that's 16K. And so we make small little fragments of this, right? And there's an art to this. You can't just like chop it up in the middle of a table. That'll confuse it. So you kind of have to have some contextual knowledge, and then you split it so that, like this gets into the heuristic, so that your size is like a small percentage of the overall context window size. And you can actually compute ahead of time how many tokens you're using. So you can kind of split it up and say, I know that for this model I have 16K, therefore my split size should never be more than, let's say, 1K. But it depends on your question, right? Sometimes it might be heavily loaded with context. Sometimes you want it heavily loaded on output. So you have to kind of decide what you're doing. And this is why evaluating is so important. You change the split size, run an evaluation loop, see if the answer is better or not. And then you create these embeddings. This is how you convert words into numbers, specifically vectors. So everyone can picture a 2D vector from math class in their mind, an x and y coordinate, some arrow pointing up in space. But these are vectors, of course, with thousands of dimensions, right? Hundreds of dimensions. So it's same kind of math, just extended to multiple dimensions. And the reason this is vector database is vector databases are good at kind of like fuzzy search. Not in the same way as Elasticsearch, but it's along those lines. And here's an example. We won't have time to get into it, but this is the model we have in Spring AI for the pipeline. So at the top, basically, we have a supplier of a list of documents. That's where we read sources, right? And so we have a JSON reader, a text reader, and these boxes, there's a PDF reader already, right? They'll just get filled in over time. And now you have to transform it. So we have a function that takes a list of documents and produces a list of documents. And this is where we start to split things, as I was talking about before. We might enhance it with metadata. So again, this is another nuance, but very important. When you're querying for things, it's not just the text, but maybe it's useful to have extracted the keywords of that text, right? So there's processing there as well, and that usually gets grouped in the metadata. So very often you pass the metadata plus the document to the AI model, and that's been shown fairly consistently to give better results. And then at the end, this is like the sink, or the load part of the ETL framework. There's a consumer of a list of documents, and in this use case, we're writing to vector stores. So Milvus, and we have an in-memory one, Neo. I'm forgetting all of them. These lists aren't complete. Postgres has a vector store. There's Pinecone, Weaviate. Again, there's a large number of these out there. So now what you do is you have your vector database all loaded with these little bit of fragments, and you ask the question, who won the gold medal for curling? What you do is you pass that question to the vector database. It does this so-called similarity search, which is this really actually accessible mathematical equation, right, of doing the dot product and dividing it by the magnitudes of the two vectors. And there's an in-memory one that we wrote, super toy example, but you get to see the basic processing, of how this works. Now you combine the two pieces of information, all the little fragments you got that were similar, right? And there's a threshold for similarity. So like if two vectors are pointing in the same direction, they're similar, pointing 90 degrees, they're not, and 180, totally unrelated. So they call it cosine similarity because cosine of 0 is 1. So therefore, if they're pointing in the right direction, it's 1. So like a threshold default number is typically like 0.75. Now you give this to the AI model, and it spits back the answer. So we'll show this in a moment here. So where is it? Here we go. So I have an endpoint called RAG, and I'll open up the code and just have a quick walkthrough. So you see now it's a service because it's getting more serious. So we did a demonstration with Microsoft over their sample app, which is a bicycle data store, bicycle shop. So you have all the bikes. You have a short description as price, and you have a long description, which is like the meat of it all, right? This goes on and on. It's electrical, has the benefit, conquer steep hills, terrain, you name it, right? So hundreds of bikes in here. And you have a, so this probably could be split up better, but this is the system prompt. It goes, you're assisting with questions about products in a bicycle catalog, right? Here's the information. It's below this document section. And here's another nuance. We noticed that if there was a question involving the price, sometimes it would just literally put the price. And it kind of worked, but it was better to say, the X so-and-so bike costs so much money, right? So you're kind of guiding it, like, just don't give me the number, kind of explain it, right? And this is where you fine-tune these things, by your eye or from user feedback, like the plus and the minus in a feedback in a textual dialogue in the UI. So normally you do this ahead of time, right? But I'm just making it super simple with an in-memory case. So I'm loading this into a list of documents. This isn't using that framework yet. It's not. It was functionized, I guess you'd say, last week. Here's an in-memory vector store. We add the documents, get a retriever, and say, given the user's message, give me the similar documents. Pass that to the system message, create a user message, create the prompt, and now generate a response. So if I call this endpoint, you see it's calling the embedding. There it is. So this is calling Azure's service. And if we look at the terminal, it says both the SwiftWrite Hybrid are great options for city commuting and so on, right? And as you get into more back and forth with a chat agent, you have to include the previous answers and your previous responses, questions. So it gets a little more involved, but this is like the essence of it. Got 5 minutes left. So code generation. This was where I started, basically. It required, pretty detailed prompt instructions. Here's the prompt instructions, right? Create Java source code, and then look, these 17 points. I couldn't believe it worked, but probably need to break this up more. So this is a work in progress, right? You have to say include build tool things, include the necessary starter dependencies, such as this, blah, blah, blah. So let me go back to the slides. Close that. So you can call this command in the Spring CLI, which did the Spring Boot new. There's also, a command called Spring Boot add, which merges two projects, but that's another thing. So this is asking AI to create code and add it to your existing app, right? And it creates a README file. And the reason it has -- preview is because you're going to iterate on this. In fact, preview should probably be the default. So you get this README file, and this should be guide apply. Right? Once you have the README file, now you apply that README file to your code base. It takes about 5 minutes, which is clearly more time than I have here. So what I've done is I've taken one that I've done before. And so I go up here. Where's the preview? Is this the preview? Yeah. Yeah, so it made this file on June 6th, so a while ago. So it looks like a normal README. It looks like a guide, right? You could write it by hand if you wanted. And here's the person entity. Here's the person repository, a service, controller, a test, and so on. And then I asked it to make links to popular places on the web for a Spring Data JPA. So this was the app we had before, right? If I do Spring Guide, apply, README, AI JPA. So now you have a new folder. Sample. And there it is, person, person service, person controller. There's the test. So if I run, I'll just package it up. And it runs a test, compiles. Hooray! You can run it. Anyway, not going to run it because I'm running out of time. So I only have 2 minutes left, so let me just go through these very briefly. This is probably more relevant for you to look up anyway. There are workshops that are being conducted by VMware and Microsoft around AI on Azure, in particular the Azure Spring Apps platform. Those are links to it, to the code. And the Cloud Foundry / Tanzu application service. Now there's kind of a little bit of a platform forming. Basically, there's an LLM tile, typically backed by the Llama 2 model from Meta, which is interesting because unlike all the other models from all the other big vendors, it's open source, and now they changed the license, free for commercial use. So there's going to be like 20 startups, I'm sure, in this room, right, going to take the Llama 2 model and building something on top of it. The Postgres tile is useful for the vector store. And then, you can use the Spring Services, Config Server, Spring Cloud Gateway, and the Spring AI. And the sample app there is this music app, which isn't the best app to use, and this little chat bot window in the bottom left there, bottom right. So 1 minute left. I wish I had more time for questions, but come down and ask questions, please. A lot of things not covered. This is a QR code for the slides, so you can get at all those links. And the roadmap is pretty aggressive. I think the field is moving very fast. The reaction from customers, this is great, when is it GA? And then you're like, I don't know. So instead of going like for depth, in terms of like 20 implementations of vector stores and 20 models, it's kind of like focus on the core abstractions, make sure we feel that those are solid, and then make a release and hope to have a GA by early January next year. So thank you very much. Really appreciate you coming. And again, feel free to come down and ask questions.